The natural partner to Euler paths and circuits, what we call Hamilton paths and circuits, comes from work by William Rowan Hamilton, also in the 18th century, again, in a bit of gamesmanship, where what he was working on was a puzzle called the Icosian Game, which is sometimes now known as Hamilton's puzzle, Hamilton's game, that sort of thing, to reference this work in particular, where what this was talking about was being able to find paths along the edges of a dodecahedron, a 12-sided polyhedron, that touched every vertex exactly once, where you can see that flattened out representation in terms of a graph as well. Where this, again, leads to the name there that we call these things Hamilton paths and Hamilton circuits, or Hamiltonian paths and circuits, in reference to that Hamilton, not the American one that they made musicals about. But here we are trying to, instead of hitting every edge, hit every vertex. And we're getting a Hamilton path or a Hamilton circuit, as you can see there with the Icosian example. We don't necessarily have to hit all of the edges. And we often won't get all of the edges to get every vertex. If you get both, it's something of a rare and special thing that really only is particularly reliable in the context of some of the very simplest graphs, things like paths and circuit graphs in particular. But next thing we're going to see here is some examples for being able to identify a Hamiltonian path or a Hamiltonian circuit in a given graph. So for this example, we want to identify a Hamilton path and a Hamilton circuit for the given graph below. And in this case, we actually have a ton of different examples for being able to find those constructions. One very easy one we can get here for a Hamilton path is to just think alphabetically. So if we take that first one up top, A to B, then go from B to C, then go from C to D, then go from D to E. Doesn't really matter to us that we didn't hit these four edges there. What matters is we've hit A, B, C, D, and E. We've hit all four, so we have our Hamilton path. And if we want our Hamilton circuit, just at that one. It's not necessarily easier, though, to find Hamilton paths and Hamilton circuits. It's actually generally a lot harder, because unlike Euler paths and Euler circuits, we don't have a nice way of being able to identify whether these should exist. We don't have a nice way of being able to tell that they must exist, except in some special cases, which is what we're going to be talking about next, is ways that we can know to look for and potentially identify Hamilton paths and Hamilton circuits in graphs.